Hello everyone, welcome to EcademicTube. So today we are going to solve a question. So first of all, read the question. It is given that a particle is moving along a straight line. So we have a particle which is moving along a straight line with an initial velocity of 6 meter per second. When it is subjected to a deceleration of minus 1.5, and this is velocity to the power 1 by 2 means under root square, where the velocity is in meter per second. So determine how much far it travels before it stops, and how much time does it take. So it is given that we have a particle and it is traveling in a straight line, and it is given that its initial velocity is 6 meter per second. So u is equal to 6 meter per second. Now it has given a deceleration of, so this is a deceleration, it is given that minus 1.5 v to the power 1 by 2. So we need to find the distance as is equal to what when it will stop, and how much time does it take to stop. Okay, so for this we will first write, as we know, we can write acceleration is equal to dv by dt. So we can write this as dv by ds into ds by dt. So we can write it like dv by ds into v. So rewriting this equation, so we can write it like ds is equal to v dv by a. Now what we'll do is we will integrate this equation to get our solution. So let's integrate this one from 0 to s. S is the distance up to which the particle had traveled before it will get stopped, and from initial to final velocity. The initial velocity is given 6 meter per second, and we know the final velocity will be equal to 0 because it will stop there. Okay, so let's integrate this. So the integration of this part will be s minus 0 will be equal to s, and integration of this part we will do, and it will come like u to v dv divided by, and we have given the expression of acceleration, so it is given minus 1.5 v to the power 1 by 2. So we can write this as 6 2v and minus 0.667 v to the power 1 by 2. Now we will integrate this one. So we will get minus 0.4444 v to the power 3 by 2 plus 6.53 2 6 to v. Okay, so as we know v is equal to 0, so the final answer will be minus of 0.4444, 0 to the power 3 by 2 plus 6.532 is equal to 6.53 meter. So before stopping, the object will move up to 6.53 meters. Now we need to calculate the taken time before it will stop. So as we know, we can write, as we know, acceleration we can written as dv by dt. So we can write it like dt is equal to dv by a. Okay, and we know we can write, or we will now integrate this one. Okay, so we can write this one like the moment when it just we started observation, its time is 0 and the time it will stop is t. So after integration the t, we will get t minus 0, and for this part we can write integration, the velocity will be, at starting it is 6 and the final velocity v, and dv as it is, and we will write the value of a 1.5 minus 1.5 v to the power 1 by 2. Now we can write t is equal to, after integration, 1.333 v to the power 1 by 2, and the value will be goes from 6 to v, and v is here equal to 0. So the final answer will be 3.266 minus 1.333 and v to the power 1 by 2. And as we know, the value of the v is equal to 0, so we will put the value of v0 there. So the final answer will be t is equal to 3.266 minus 1.333 and 0 to the power 1 by 2, and it will come to 3.27 second. So the object took 3.2 seconds to get stopped. So I hope you got the concept behind it, and it is just normal integration. There is no need of extra effort for that. These are the easy questions. So thank you for watching this video, and for further doubts and updates you can contact us in this WhatsApp number, or you can mail us in this email ID, and we will try to provide you solution as much efficient as we can. Thanks for watching.